Welcome friends, please remember on this channel I post videos on more advanced math concepts. So a, b, c are vectors show that the magnitude of a plus b squared plus the magnitude of a minus b squared is equal to 2, multiplying the magnitude of a squared plus twice the magnitude of b squared, and then also interpret this result geometrically. We need some tools we have to establish and remind ourselves of. First of all, a dotted with a. So this is something of the form a1 a2 dotted with a1 and then a2, like that. Brackets, these angled ones are the ones I use for vectors. So that's going to give you a1 squared plus, by the definition of the dot product here, a2 squared. But that's just equivalent to writing the magnitude of a1 squared plus a2 squared, this whole quantity squared, because these are inverse operations. And of course, then this really is just the magnitude of the vector. So in other words, a squared the magnitude there. Okay, so now that we have this tool, let's just work on each of these expressions independently, and then we can put them together at the very end. All right, so now let's work out a plus b, that quantity squared. So how can we use this tool with this expression? Remember, since it's a plus b, this is a vector magnitude and it's squared, then you can just apply this definition right here, see? Just work it backwards to this step. It just happens in this example that a plus b is a sum of two vectors. That's the same as if you had a single vector, just two symbols, that's all. So if you needed to, you could, for example, like rename this for yourself C, but the same logic would apply. So you're going to have a plus b, in other words, dotted with a plus b, dot product. So now we're going to have a dotted with a, which is a dotted with a plus a dotted with b. Okay, plus here b dotted with a, so b dotted with a, and then plus b dotted with b. So plus b dotted with b. Now we already know from this work right here that, for example, a dotted with a is just the magnitude of a quantity squared. So this is going to be the magnitude of a squared. This term repeats, so it's going to be 2a dotted with b plus b dotted with b, again, is just the magnitude of b quantity squared. Now, let's look what happens when we do the a minus b part here. Okay, I can probably fit that here. So it's going to be a minus b in the magnitude of this quantity squared. Let me be clear so we don't get confused. I'm going to separate it this way. So now we're going to have a minus b quantity squared. It's going to give you a minus b dotted with a minus b this way. So dot them, okay. So now distribute. A goes to a, so it's a dotted with a. Then it's a dotted with negative b, so here I have to be careful. So that's a dot. It's going to be minus a dotted with b, and then dot the negative b with the a to get another basically a dotted with b. Just, you don't have to write b dotted with a, you can write negative a dotted with b. And then the negative and negative will cancel, and you're going to have b dotted with b at the end. So b dotted with b with a positive there. So now this is going to be, this quantity again, we know already is a magnitude squared minus, these repeat, two of them, so minus 2a dotted with b. And then at the end, it's going to give us here, well, b dotted with b is just going to give you the magnitude of b squared. We're looking for this quantity here added to this quantity here. So now we have to just add these, right? So a plus b, this quantity squared, plus this a minus b, that quantity squared. Carry that out over here. So in other words, a plus b, that quantity squared, plus a minus b, that quantity squared. And then you just worked with this carefully. So look what happens here when I add them. I'm going to add, maybe it's a different color. This part gets added to this part right here. So what does that mean? These are just numbers in the end. So it's 2 magnitude of a squared. Look what happens with these. This is positive 2ab. And this is a negative 2ab. So they will cancel. And then you have this b right here. So again, let me emphasize this part right here. That's just going to add up with this part right there. So that will give us then at the end here, attach the term magnitude of b quantity squared. And then a 2, right? Because this and this one is doubled. So here we've proven our statement. So now let's interpret the results geometrically. Imagine this is your vector a, and imagine this is like the vector b. So then a plus b, which is what this quantity here is, Well, you just take a copy of B and you place it here. And then you draw this vector. So here I have to be careful. The green vector right here, that represents the sum, right? So this is A plus B quantity this way. In terms of the length, at least, it's the magnitude. Now, what about A minus B? That's like the vector that has to be added to B to give you A. So that vector I will represent in blue as this vector right here. Okay, so the blue vector then is the A minus B, right? And its length would be this, the magnitude of A minus B. So if you look at this equation, what this says is the following, that go around the shape. A plus B is this, that's a diagonal, you square it, and if you add to it the square of the difference, it's equal simply to the sum of the squares of the sides. Why is that the case? Well, look, right, this means magnitude of A squared, because of the 2, it's another magnitude of A squared. This is twice, so it's going to be a B squared plus another B squared, right? So A, B, right? This would be another A, and this would be another B right here, you see? Like that. So go around the shape, square these magnitudes, add them together, and the result is equal to just taking whatever this magnitude is and adding to it the square of this other magnitude of that second diagonal. That's it for this one. Please be sure to subscribe and like if you enjoy math videos at this level.